Hello, in this lesson on flowcharts, we're going to first of all look at this video about commercial greenhouses where they grow vegetables.
You are looking at the most sophisticated, technically advanced greenhouse farming operation in existence. 125 acres of glass structures just an hour north of LA. This is Howling Nurseries. What the space shuttle is to aviation, this is to farming.
So would it be fair to say that this is probably the most high-tech, state-of-the-art greenhouse in the country?
In the world.
Inside are endless rows of perfect tomatoes growing in a nutrient-rich liquid diet. A diet that requires no soil, none at all.
We feed it the nitrogen and the potassium and all the other elements such as iron and zinc. Computers monitor everything. So it's really quite a step away from the field farming to a much more scientific level where you'll get 20 times the production per acre in a facility like this.
And the waste? In the field, nearly half of all tomatoes don't meet consumer standards. Here, only 2% are rejected.
This holds water. It's essentially inert. It's also a very porous media.
The plants sink their roots in coconut fiber.
It drains, and it's also a natural product. When we're done with it, it goes out to green waste, and it can be composted and recycled.
These vines grow about a foot a week, and since it's all enclosed, there are no bugs, no weeds, no fungus. That means no pesticides, no herbicides, no fungicides.
All those things that none of us really want to use. The greenhouse basically eliminates 98% of the use of those products.
But these tomatoes are not organic.
The real position on organic is then you can't feed them fertilizers, liquid fertilizers, or chemical fertilizers, which we do here.
You do feed fertilizers, okay.
But we think of ourselves as being better than organic.
While most farmers gauge the seasons and watch for changing weather, Casey Howling's greenhouses have just one season, the growing season. Crops are grown year-round in an environment that can only be called tomato nirvana. What makes this greenhouse more advanced than any other are the computer systems that control the temperature, the humidity, and the carbon dioxide levels.
When do I start the water? How much water do I give them? What's the nutrient levels? There's a huge amount of factors.
So why aren't other farmers copying this operation? Professor Terry Fujimoto runs a hydroponic greenhouse at Cal Poly Pomona. So if hydroponic farming is so fantastic, then what is keeping it from spreading across California?
Money, and it's very expensive to let's say take an acre and convert it into a hydroponic operations.
The most recent expansion of the Howling's nursery cost $50 million. And there are still some circumstances beyond their control. In 2000, before better screens were installed, a tiny but powerful pest got through.
We had a plague here, it was called the whitefly plague. We ended up having to clean the whole facility out and replant it all. And that was a pretty significant hit that we took. But not only did that happen, that was also the same time that the blackouts were happening in California. So it was almost like the perfect storm.
They have since built their own power source. Solar panels now give them nearly total energy independence.
This one's done.
These tomatoes do cost a bit more, but customers are buying. Greenhouse farming is still a very small part of California's $36 billion agriculture economy. But experts say it's growing by a healthy 10% a year. And its productivity is unmatched. If these tomatoes were grown in fields, you would need 24 times as much land. And that's why the future of farming may look like this.
So that's very interesting because as the world's population grows and we run out of space for farming to feed everybody, we're going to need solutions like that greenhouse to be able to feed everybody. And computers play a large role in that. And that's what we're going to be looking at today, is how we use flowcharts to make sure a greenhouse is running as it should, because it's too much work for a human to monitor. Before I do that, I just wanted to show you this, which I found out whilst I was researching this project. Greenhouses are a huge part of our economy now, because that video was from 9 years ago, so it's grown since then. If you look at this picture from Spain, you may not notice anything unusual to start with. As we zoom in, you might notice this white area down here. Now that may not mean very much to you from this distance. Might be unrecognizable. You just think, oh, it's part of the landscape. But as we zoom in, closer and closer and closer, you can actually see this area of Spain is made up completely of greenhouses. So all of these white buildings here, where you'd normally expect to see green, they're all greenhouses that have been completely rammed together into a small space. And apparently this is about, I think I read 30 miles across, something like that. Okay, so inside a greenhouse, it's very complicated, as they say in the video, and they're looking at all the nutrients inside that they're going to feed the plants. But we can basically say, in our flowchart, we're going to look at 4 different things. We're going to think, is the temperature in the greenhouse warm enough? So in the winter, is there enough heat in there? So if there's not, they're going to need to use heaters to heat up the air. Is there enough water given to the plants? And if not, they're going to need to feed the plants water either through a sprinkler or through, in that case, hydroponics, which is water straight to the roots. Is it too hot or humid inside the greenhouse? In which case they're going to need to get fresh air in, and we'll do that basically by opening some windows in our flowchart. And is there enough light? If it was a particularly cloudy day or in the evening or night time, are they going to need to turn lights on to keep these plants growing throughout the night? We're going to draw a flow diagram in Flowchart to represent those decisions we're going to need to make. So do we turn the heaters on or not? Go to the Flowchart's homepage, press login. You should already have an account if you've done the previous lessons. Go to Office 365 here. You may get signed in automatically, or you may need to type in your password as you've done previously. I recently found out that you can only have a maximum of 3 charts at one time. So if you have an old chart, you will need to delete. If you've already got 3 charts, I should say, then you're going to need to delete one of them. So do the new one and delete that one. The new one. Okay, so our 4 factors that we need to think about are the heaters. So we can never let our greenhouse drop below 30 degrees Celsius. So if it does, we're going to need to turn the heaters on. So we're going to need to do something in our flowchart about that. Water levels, we're going to need to measure the level of the water. We're going to need to measure the moisture level in the water. These are percentages you can see on screen here. So let's say we have medium soil, like soil you would find in your garden. And it's saying if it gets below 88% moisture, then water is going to need to be added. So we'll have to have a measure, a hydrometer, I guess, or something to measure the water to see if water needs to be added. So we'll have something in our flowchart. If it gets below 88, add water. Humidity. Now, the humidity is quite complicated, but I found on this website that the humidity of the air should be around between 50 and 70. If it gets above 70, we'll open the windows. If it gets below 50, we'll add some water to the air with a sprinkler or a spray. And then finally, the plants need at least 8 hours of sunlight a day. So if it looks like they're going to get less than 8 hours, then we're going to need to turn the lights on for the rest of the day. Okay, so in our greenhouse, we've got 4 things we need to measure. So because we're measuring, we're going to use this input-output box, a data box here. So the first thing I'm going to measure is the temperature. So let's take a data box over. So measure the temperature and then make a decision. If the temperature is less than 30 degrees, we're going to want to send an output to the heaters to be turned on. So remember, data is when you're taking something in and sending something out. So that might be taking a measurement in and sending a message out to turn on heaters. Now, if the temperature is more than 30, so is the temperature less than 30? No. Then we're going to send a message to the heaters to turn them off. Now, it doesn't matter if they're already off. If the temperature is already above 30 and they're off, but you send another message to make sure it's off, it's not going to affect the heater if you send it 2 messages to be off. But it's just to make sure that it is definitely off. Okay, so that should deal with the temperature of the greenhouse. If it's less than 30 turn the heater on. If it's more than 30, just make sure it's off. Resize this to make sure they're the same. Oops. Then we need to move on to our next thing in our greenhouse, which is the water of the soil. So the next, we're going to need to measure the water level in the soil. So I'll bring over another input box. And the way this flowchart works is you've turned on the heaters, but then what happens? Well, you're basically going to need an arrow coming from either of these places here. So whether we turn the heaters on or off, we're going to need an arrow going from there to our next stage in the flowchart. So from there to there, there to there, and from here to here. And whichever we did, we're going to want to come through now and measure the soil moisture level. So then make another decision. Say, so we said moisture less than 88%. If the moisture is less than 88%, if the answer to that is yes, we're going to want to turn on water supply. And if it's no, we need to turn off the water supply. And because we're sending a signal out to the watering machine, whatever it happens to be, it's a data box we're going to need because it's a signal going out. Okay, so I want you to think what's going to happen next now. I want you to do the rest on your own. So you're going to probably have some arrows coming down like we did. So which decision you made, whether to turn on the water or off the water, you're going to need to now go to the next step in your chart. So think about what that might be. And then we don't just want to do this one time. We don't just want to measure the temperature once, then the water, then everything else, and then stop. We're going to need to have a situation that when you get to the bottom of all your decision making, you then in some way come from the bottom. I don't know if we're going to be able to do it like this. Let's draw this box over. Whatever happens at the very end, you're going to want to then check everything all over again. So you want to come all the way up to the very top. I've not done it very well here. And start the whole process again. Now, hopefully we can, there we go. So once you've checked the very last thing, which will be the light, then you're going to want to come all the way up to the top and start measuring everything again. Because if you've turned on the heaters, you need to then check to see if it's now time to turn them off. Now, if any of you who are worried that you might be leaving the heaters on for too long, so if you have to go through all of this before you then come back and check that the heaters, whether they need to be turned on or off, please bear in mind that a computer can do all of this in just a few milliseconds. So by the time you've turned that heater on, it's only going to be a few milliseconds before the computer goes all the way through, very quick, comes back up and is checking again anyway. So don't worry if you're concerned that you'll be leaving the heater on for too long or the water supply on for too long. The computer will check those things extremely quickly.